Welcome to another test and teardown video. We're gonna start on the floor this time. Oh man, this is big and it's heavy. I just measured it to nearly 28 kilos and it's really solid. So this is a Rohde Schwarz measurement transmitter or sender, so you can test receivers. This is actually what it says here. Receiver test center or generator, if we translate this. So it goes from 4 to 300 megahertz. And Rohde Schwarz München, that will be in Munich, standard signal generator. Pretty cool. And you can't dial this, so you need to dial on that one, and it takes forever to do. But it's, so this is the output, I guess, and this is super loose, so I guess this is not connected to anything internally, so that's definitely something wrong. That's broken, an arm or something. I guess this will be, oh no, this is stuck, so that we cannot turn. I don't have any 716 connectors, so that is a problem to interface this. So why are they using 716? And this is the frequency range selector, and it is like really, it feels like I'm moving 10 kilos of something. So there's definitely something big moving around in here. I guess this is all the different types of modulation. External AM, FM. Look, it is also very rusty or corroded. So if this is how it looks on the outside, I guess it's probably looking quite bad on the inside. See here. So I guess this was stored for many years in a shed or something, maybe even outside. So that is not so good. I guess this is the aus, so this is the on-off switch actually. And then you go through different modulations. Number 4 is unmodulated carrier. This is what we're going to try first, and we're going to go down to the lowest frequency range, and then we're just going to put some bananas in here and a scope and see if we can see something. What is this B? This got to be the output attenuator of some sort, and so maybe, I don't know, you actually know what the heck is this. So this says microvolts, right? Okay, so this is in microvolts times this multiplier, I guess, right? So that means this, I don't know. I think we need to open it first, because especially because this knob is locked, and there is a check. This one is a little bit interesting. Check tube. So when you push this, I guess one of those meters need to indicate. You see? This is, it says here the indication when you are pushing this test. Then it should probably go for the red here, I guess. And this will be deviation. AM, FM, indication, how much you got, right? Yeah, I'm a little bit worried about plugging this in before I have seen it inside. I better do that, because it's gonna blow up or something. that was something. I lifted up the entire main unit, and look at that. So, I mean, it's about a third of this box. There's actually maybe a power supply or an input filter or some kind of stuff. There is a connector like this and some steering pins for the plug-in, and this is of course all the RF stuff. It looks like we're supposed to lift it up like this, so we should maybe try and unscrew here. Also, I see in the bottom, oh yeah, that's definitely the power supply, so we'll be able to access that. And it seems like the back side we can also open here. I think we should try and open and see how the power supply is made. But there's probably some filters and stuff here. And yeah, this unit is just beyond repair. It's completely crusty and completely rusty, and the entire unit is also rusty. But anyway, doesn't matter if it's beyond repair. We're still going to investigate exactly how it was designed. That just means we can't repair it and we can't power it up, but it still contains a lot of cool design and manufacturing choices. And yeah, let's try and open here. So this is the mains entry point. 2 fuses. 1 fuse in each wire. That is so cool. And then look at this, another room here for the input stuff, and then input filter mounted in the metal like this. I can't pull this out, so we need to figure out how to open this. This seems to be, yeah, how it's mounted. So this is definitely a really well designed input filter, and this is the bottom. Whoa, where we see some of the power supply components. Let's see if we can get a little bit more light in here. You can see it's completely corroded everything. This one got quite a lot of water, and that's just too bad. We still see some tube sockets. This one is not original, so somebody repaired something here a million years ago. Oh, look at those transistors. They are very highly desirable spare parts. I'm definitely going to save those so I can bring some other electronics back to life, because you cannot find stuff like this anywhere. So this is the mains input filter again. I cut it out and look at that. We got a capacitor, inductor, capacitor, inductor, capacitor. I'm definitely going to measure the frequency response of this filter. That is very cool design, and we're probably going to open it as well if we can. But wow, that we're gonna save for later. So now we are inside on the very back side of the unit, and it looks like it again. The power supply is full of all sorts of cool stuff. That was selenium rectifiers. I believe there will be 2 selenium rectifiers, because I did sneak peek a little bit in the schematic. And what is that? Is that a tube that is white on the top? Let's have a look. Yep, that means we have lost the vacuum. And that is a high voltage rectifier diode or something. We also got another tube here. We also got some other labels for tubes, so they're probably inside there. And as far as I can see, we've got a screw there and a screw there. So let's take those out and see if we can pull out the entire power supply unit. Whew. I just lifted up the power supply. What's in here in the bottom? Look at this case. It is 5mm material, maybe even more down here, and it is cast in aluminium in one piece. Ladies and gentlemen, how the heck did they do this? So this case is, maybe they had something in there in different pieces they could take out or something. I can even see some names or numbers written down here in in the casting. I guess you can see this as well. Yeah, and then they milled this edge really nice and flat, because this is where the power supply go down to, and this is of course the front that is also milled a little bit, or is it just clean from paint and stuff? Let's look a little bit more on the power supply. This is the heavy side. So we've got some really big boys. High voltage things. And what is that? Is a transistor. And the other two transistors, so we got actually also some transistor stuff. Is this really original? And then we got the selenium rectifier. And this is a CTP 1109 maybe. EF80 PL881, is that one? Yeah. And this is of course a voltage regulator, the 8582 EF80. But what is that thingy? Rundfunk thingy. And we got all those wires coming out of it. So that is a little bit funny. That I need to investigate what that is. Oh, now I know what that is. See this transistor together with those two transistors. And you know what that is? See? This is a xenodiode, a 5-volt xenodiode. So that is, of course, a regulated power supply, a regulated DC for the filaments. So this thing is running off pure DC. How cool is that? And those transistors are, as far as I can see, OC604, right? Yeah, I guess that is what it is. They're pretty cool. This is the voltage selector with information about mains fuses. And look how they made, this is a really cute metal bridge. You can move through those 4 different positions. Then you can change the mains supply voltage, and this is our of course the fuse ratings, and then you put those fuses in the rear panel. Oh, yeah, of course I had to open this thing. And this is, anybody guess? Didn't I tell you guys that I saw in the schematic 2 selenium rectifiers? This is, of course, the other one. Oh. So all those plates are diodes. Maybe we should try and measure a few of them. That's quite fun. But yeah, a real beautiful one for high voltage. So look at this is one of the elements of the selenium rectifier, and I'm in diode measurement. So let's look from this back side to the front side. See, there's nothing. So let's reverse it and measure the other way. 0.35 volts for one element. Let's take another element and just see if it's the same. Oh, damn it. Let's try again. 0.36. So yeah, selenium rectifier diodes. So let's look at the main unit, and this is exactly what I said about the output attenuator. There is a wire that is broken. I don't know exactly where this wire is supposed to go, but maybe it's that one. Can this? Yes, that one can move. So that means the wire was this way around, probably. Good. And I haven't figured out. So this is the main attenuator, or you know, the I don't know. Let's see if we can get some more light in here. This is connected to all those wheels and whatnot. And this is not moving whatsoever, but everything here is completely corroded. See how everything is just crusty, and everything actually falls apart. When I move stuff, it's just totally rusted all the way through. So there's just no way to repair any of this, no matter what you do. It's just completely crusty. Oh yeah, this is the frequency dial, and it's moving all sorts of dials and gears into this main frequency resonator thing, and everything here that is connected to the front panel, like meters and stuff. Look how well they are filtered. Again, you see capacitor, inductor, capacitor. So we got some filters on everything. They really went all the way through. See, there's again a tube with no vacuum in it. And all the trimmers for alignment of everything is moved all the way up here. And let's see if I can move this big boy. Isn't that just cute? Super, super good service, friendly adjustment, alignment. And again, here we got capacitors and inductors in one big line in this big resonator thing. We got some tubes in there. And this is the power supply connector. I'm definitely gonna open everything here so we can see what is inside. That's gonna be interesting. So I'm going to take off all the screws and let's have a look. Hey, another one. That was a tricksy one. Oh, look at that. It's a slide in. Whoa, nice. So that was a slide in and then it locks up. How cute. Ooh, we got a rotary switchy connected to some other things. It's a beautiful made, and again, thick, solid, but again, it needs to be thick and solid for frequency stability and performance. So this is not just for the weight. This is definitely for performance. Here, this is what matters. Anything else can be thin, flimsy stuff, but of course it's not. And then we have these shielded, and this is also very, very heavy. This is brass or something. It is very heavy. I'm going to find out what that is. And they painted it black on the inside, so the tube will radiate its heat to this, and then it will dissipate into the metal. Otherwise it's gonna overheat. So that is pretty cute. That one we're gonna save. Well, what else? We got some... What is going on here? Got some filters, and then we're in here. A little diode that is doing what? That is funny, isn't it? So what are we doing in here? I'm a little bit unsure. Okay, look at that. Is the capacity and this is a diode. So this is a capacity diode, right? For modulation, FM modulation. And then this goes straight into the resonance capacitor adjustable thingy here, right? Okay, that is cute. There was another one. Another shielded tube there. And again, they're doing this funny tricks. And I wonder what that is down there. That looks a little bit cute. We got some trimmers to do some stuff. There's definitely some funny things going on in here. And everything is filtered in those metal cabinets like this. Whoa. I am very impressed. I really look forward to open some of those filters. Oh, sexy little tube. So I rotated it a little bit, and this is the top. And they keep doing it this way. I've never seen this method before, actually. It's really, really funny. And this is a... okay. A switch of some sort is connected to... ah. Okay, so this... some sort of a... okay, now I can see it. There's definitely a switch down there doing flippity floppity. That is connected to the frequency or attenuator dial or something of that. No. Ooh. They're really beautiful, those. So this is coated with something or some silver coating or some other sort of coating. I think they're brass or something because they're way too heavy. That is some funny stuff. I did not expect it to be this super funky build. But this thing, EC81, huh? Cute little one. I didn't expect it to build this because it's only 300 megahertz. So why are they building this like a tank and like it's a 5 gigahertz thing? It's just built to the highest possible standard anybody could imagine we could do this. It's like they had a meeting and they agreed to, hey, let's do this the highest level possible, right? Most expensive, most fancy, most crazy level of everything. Wow, it's just amazing. I am in the bottom part. I've removed a lot of the big cable harness stuff here because I'm going to take out the entire front unit, so we're gonna see a lot more here. But I was having a lot of fun, and this is the output coaxial cable, and that is soldered like this. And you see the color here? This is lead. This is a solid lead coax cable, and look at the proof. I can take it, move it, and then it's gonna stay. So this is lead. How cool is that? And it looks exactly like lead. Ha! I've never seen a lead cable before. And again, this is modulation input, and they're doing everything with those kind of filters. It's just all over the place. See all the BNC. No, those are banana. Yeah, banana connectors for low frequency input outputs and stuff. And again, it's full of capacitors and inductors and stuff. Wow. We're going to see how we can get in here and if we can disassemble some more. Get into this thing. They're completely rotten, all those components. The corrosion is just everywhere. It got a lot of water over many years. Just removed all the potentiometers for alignments of everything, and we can now see a lot more in here. Look at those rotary switches. Aren't they just cute? Let me see if I can show you guys how this works. See, when I rotate the knob, I need some more light in here. Let's see if... Is this better? Yeah, that is better. No, it's not. Anyway, it's difficult to take pictures of, I guess. Maybe if we pull out... Ooh, yes! That is what I did not want to happen. And this is how you cut your fingers really bad. But luckily, nothing happened. The other one here is, of course, intact, so this one I can pull. Oh, they're really tough in the socket, so they're both EF80s. Good. Well, so this is the band switch for the different frequency bands. Let me see if I can turn on this one. Yeah. Oh, now that looks beautiful. See, if I dial this around, clunk. So that is how it works. We got some different inductors for all the different bands and whatnot in here. I don't know if we can see a lot more. Oh, we also got one more diode and one more little capacitor down there. That's really beautiful. Yeah, I really like this kind of mechanics. Super stable. I kind of knew it. Aren't they just pro? So that is the 2 meters. And again, there's a new closed room with the filter and everything in here. Isn't that just how you do it when you are pro to the maximum? Look a little bit more on the bottom view, because here that's all the different modulations and whatnot. And this is the fantastic band switch. And there's a very big ball bearing and an arm that hammers in and out here. So this is what gives it all its stability. And there's another switch here that's connected to that as well. And this is the output level attenuator or something. It's just completely stuck. So I need to unhook all those couplings, because otherwise there's no way I can take this entire front unit away from the front plate. So that is a little bit... So I don't know if you see the similarities, but my wife says this looks like a microwave oven. Really? Alright, pretty cool. So this is the frequency ranges, and this is the ball bearings that hammers in and locks everything very accurately. And that is the... Aha! So when this is turned, it hits this switch or something. But this one just can't turn at all. It's completely locked. Yeah. You see? Bonk. Amazing design. But of course you can see it's completely rusted, corroded all over the place. Just too bad. It could have been fun to get this up and running, but that is just not going to happen when it is so crusty. I see a little bit of marks, handwritten marks all over the place. I also saw some dates and some other numbers. See, here's a little number 7, and it's quite fun to see those little handwritten stuff. And this is the frequency dial. This is all there is to it. Of course it needs to know where it is so it can compensate for some stuff. But see, it is actually this double variable capacitor in here. I don't know if we can get a good picture of it before I kind of open it a little bit more. Let's see, it's here. It is made of this big and fat and stable. Oh, yeah, here I can see. Let me see if I can get a little bit more. No, we got all the light we can possibly throw in there. I don't know how to show this. Yeah, here we go. This is the capacitor. Oh my god. It looks like it's designed for a megawatt. Wow, look at that. That is some tough stuff. Yeah. And it feels like it is touching something it is not supposed to touch. Can you hear this? This sounds like metal against metal. So this is definitely broken. So that's just completely beyond repair everywhere I look. Can't wait to look inside these filters. They look a lot like the same. So let's do this together, shall we? I took off the 2 screws and... Oi! Yeah, oh, that is some sexy filter. So this is definitely a really, really nice coil. And then we got a capacitor to ground. And then we can pull up a new one. Oh, it's different. Of course it is different. Ooh, it's made in layers and all that kind of stuff. Let's try and cut this and have a look. Yeah, that is definitely some sexy way to do it. Oh, look what they did. This capacitor has like an input and output, and then the ground on the other side. So this is like a feed through kind of style what they're trying to achieve here. So it's super attenuating. They know what they're doing. That is just so much new level. I mean, in 1950 something, they are just from the moon. And then see, this is the input to the capacitor, but they got it on the output, and then they feed this signal through here, and now it's isolated. Whoa, they mean business. I'm going to save a few of these as they are and see if I can get them out and measure, you know, the broadband attenuation and how they work. Because I think with a modern spectrum analyzer I should be able to measure exactly what is going on in some of those filters. That could be a lot of fun. But how can I get this part off without breaking the ground seal or the ground connection here? I think they're using the same screws here to actually mount the whole thing, so I need to take it apart and then put it back together. That is a little bit annoying. So here we go. This is that capacitor. 2 nano, 4 ohms. Well, that's pretty sexy. I just couldn't make make that kind of go away. It looks like there's supposed to be a capacitor and then the inductor, right? And when I pull this apart, all I see is an inductor. But here, look at that. This is the entry. And this piece of metal here is actually screwed on the back side. Ooh, isolation stuff. So here you got your capacitor. What are they doing? They are just at a different level. See, and it is isolated from here. I mean, here we go. So this is the input. And there's a little piece of isolation. I don't know if you guys can see this, but if I pull this through, look. See, this little plastic is isolation and is insanely thin. And here you got your capacitor. They went all the way maximum, guys. That's what I'm saying. Is this really necessary? I don't think so. This is the output attenuator, and I just need to see how that works before I can go to sleep. I am sorry, but that is going to happen tonight. We're gonna go in there. So yeah, I cut this cool lead cable. That was definitely something. So there's a mechanical rotary attenuator of some fantastic origin in here. Somehow we need to get in there, but there's no way we can rotate anything. And this is the back side of that thing is looking like that. Absolutely crazy. So how are we gonna go in there? Don't you just know this? Something is preventing me or postponing what is definitely inevitable. I'm going to figure this out one way or the other, or I can go and pick up some more heavy duty tools. And no, it's not the resistor that is holding it. So what the heck is holding this thing? Is it going to be the crowbar or the angle grinder, or is there a screw somewhere? There's definitely a little round thingy here that feeds a signal from that capacitor through a little hole in here where all the magic stuff happens. Why don't you just go away here? Finally we're getting somewhere. Look at that switch I was talking about earlier. Even inside that switch we got capacitors. So it's filtered. And that was this thing. And correctly enough, there was a round tube with a signal inside going from this compartment to the output attenuator unit. So this is the output, and it consists of two parts: a main stepped attenuator of some sort, or a coupling of something, we don't know yet, but you can hear this. So that sounds like a switch of some sort. And then we got the variable part, and this is really cute. Look what they did. It looks a little bit like just a capacitor, but if you see, the capacitor is divided in two halves, and that is actually a capacitive voltage divider. So you see two parts, two halves of it is coupling. Now all is coupled to this one, and now more and more gets coupled to the other part of it, right? So this is actually a capacitive voltage divider for the variable part of it, and it runs super smooth. And this is where we had this thin wire going that was broken. But I want us really want to go all the way into this stepped attenuator and see how that works. So what was the whole idea about that one? But I bet I can get in there. And this is the sexy cable. So that is a capacitor and the input. And then they actually explain the different resistors this consists of. Have you ever seen an attenuator made like this? So how do we open this thing? Maybe we just take off the top. Maybe that is enough, because I think it's difficult to get access to those screws, because then I need to hammer this out, and oh, that looks difficult. I mean, this is supposed to be a 300 megahertz attenuator, but I bet this one runs up to gigahertz, because look what they're doing here. See, this is the rotary part of it, and it's connecting in and out of everything here in a really, really nice way. So how do we get into the resistors in here too? Hey, that is not easy. Just no way on earth I could hammer out this little locking thing, and I tried to drill it out, and this is just harder than anything else. But luckily the shaft was made of nothing, so I could easily cut that. And now we are back to business, and we can unscrew this thing and have a look what they did. But those screws, they are so tight. I was almost upstanding on the tool here to get this out. Whew. And then there's this little ball. So how are we gonna get this? Ooh, is there another one? Yes, there is. Oh man, they just love those. How am I going to get this out? Oh no, I can't do that. But I'm not going to stop now. Oh, what can I do? I don't know. Okay, so we are in, finally. Whew, that was some tough. So it looks like they filled this entire thing up with some transparent resin or something. Damn it. I figured it out. So they're connected with a lot of different resistors like this to ground, and okay, so this is the actual attenuator, made in different little rooms with a little rotary thing here. It's quite beautiful, but now it's broken. That's just in the name of science. Could have been fun to know what kind of frequencies this would work to, but yeah, when we got resistors like this, flying leads all over the place and stuff like that, yeah, probably 300 megahertz, no big deal, but not a lot more anyway. So anyway, that was a lot of fun to see all the cool things they did, and imagine building this in 1950 something. Wow. Where the variable capacitor or the variable attenuator was located. And I'm actually now happy that I pulled this out. It was really difficult to pull out, and it's made with a really nice ball bearing and everything. But there's some very important detail here that you got to see. Can you see this? Every second of the moving parts, they are connected in like a quarks kind of way. I don't know if this is easy to see, but it's definitely made really, really special. So you can see what I'm talking about. The input and the outputs and the different parts. Oh man, this is amazing what they have done here. They are just the really, really most clever dudes around. That is a piece of ingenuity. They've been thinking about this for 1,000,000 hours. I'm trying to get into the frequency oscillator generator part of it and see, this is the capacitor, and it is now going around here without touching anything actually. So that is fantastic, and it is coupled to this dial here. This is actually the geared input of the frequency dial, right? And see, we got a couple of these on here, so it presses this shaft to the other shaft that's inside, and this is the alignment of these two is actually how you calibrate the frequency. So that's pretty cool. I am getting all sweaty and all knocked up. They're not saving on the screws, and they're definitely not saving on the torque they use to tighten those screws. I don't know if you can see this, but there's like, I don't know how many places I got beaten up today. I think this is God's punishment for opening this unit. I really want to get the super sexy variable capacitor out, but maybe there's not so much use for that anymore, because now I realize this is a ceramic shaft, and that is also broken, and because this one was mechanically connected to the front plate and the gears, so this unit was of course dropped, and this is also why we see some of those wheels not being able to turn, because the whole unit is bent and twisted a little bit. We also saw broken tubes and stuff like that. Clear evidence of this one being dropped or thrown from a high distance, or maybe dropped like a couple of feet, because it's damn it, because I really would like to have this really, really cute capacitor out, and it's difficult to figure out how to get this out, because they got some screws in here. How did they manage to, and there's another one here, how did they do that? Because I don't see any holes here for the screwdriver, and I am not able to do that, and this means I can't get this thing out because it's mounted on a plate here. This is in the way. But I think I'm not going to waste any more time with this. It's just a capacitor, but it was made super thick with some really, I don't know if we can show you guys this. I think I already tried my very best, but it is really cute. But anyway, it was a lot of fun, and it is really built the best they could possibly do it all over. I love it. Now that I've removed the bearings, it's actually easier to pull around with this and then show you guys that the connection here is of course the resonant one, the selected one, and look, all the others are shorted. See? So they don't cause any other kind of resonances and stuff. Yeah, I mean, have you seen this before? They just put in all the details for every little detail. Detail all over. Let's do it. Perfect. Oh man. Of course, I could get this capacitor out. It is just really, really beautiful. And of course I can repair the broken shaft because I can loosen this screw and then I can pull it out, and then I can take this one, because I bet they're using exactly the same. See? That is what they're doing, because everything here was built from scratch. That was a long and tough night, but of course I managed to figure out how to repair this. Oh, this is just a super cute variable capacitor. I really love it. It's just sometimes I really like to keep some of those fancy souvenirs, just because it was really, really bad that I couldn't save this unit because it was just too corroded. It's still a little bit dirty, this one, but maybe I can clean this up a little bit, but it was just all over the place. But this is a cute trimmer variable capacitor. I also took apart the meters, and they're actually also stuck or corroded inside. So when I move this, obviously now it's not so easy to show this. Yeah, here we go. So it's kind of stuck somewhere. It will, yeah, also here. It depends. There's definitely something wrong. And the other one is also doing it. And they got different sensitivity. And look, this is exactly how they adjust the sensitivity. This piece of metal that kind of shorts the magnetic field. And this way you can fine-tune the sensitivity of the meter. So that's pretty cool. That is how it's done. So to be able to measure the insertion loss of the mains filter, I got my classic impedance and loss bridge here, or it's just a matched board actually. I did a video on this as well, so if you want to see that, please go ahead. Anyway, here's the mains filter, or actually half of it. There's a DC resistance of a half an ohm, 0.5 ohm. That's a crazy. So I cut this board in half and connected each side, and now it is in 50 ohm environment due to the attenuators. And I have now, on a reference board with exactly the same attenuators, I have now performed a zero normalization of a full span. So this is from 0 to 3.2 gigahertz. Now let's put on the mains filter, right? So this is the mains filter, and what the heck? Of course I didn't add the gain stages and stuff like that. But so far I can't see anything at all. This is the same curve I got if I disconnect the cables. Are you crazy? So now I have turned on the preamp and I've removed the attenuator. So now I got, I don't know, 90 dB of dynamic range. So look what happens when I touch the metal. Here the metal is not connected in like a metal cup as it was in the unit. And see what happens if I touch it like this. Then my attenuation is really, really crazy, from 70 to 80 dB. That is crazy. I'm trying to measure a little bit more on this filter. I'm so sorry about all this dirt and stuff. And this is 0 to 10 megahertz, where it starts to be really, really good. So 5 megahertz, we got like 50 dB. So yeah, this is the attenuation of the mains input filter. So they're really going after the megahertz and not for the kilohertz. Lastly, I wanted to see how the gearbox for the frequency dial is made. And of course, it is very, very crusty and corroded all over the place. I think it's really, really bad in here. It was outside, left outside in the rain or something like that. But of course, this is also very, very old, this unit. We can see it here all the way around. Due to all the different frequency bands, of course we need to have all these different indications because it's a little bit odd, all the different frequency ranges, as you can see here, you know, 4 to 6.5, or then 6.1 to 10.3, and it's just, everything is just all over once again. Well, if they made this like 4 to 8, I don't know, 8 to, I don't know, whatever, it's, so they could reuse the I don't know, they couldn't figure it out like that. So yeah, anyway, let me try and see if we can, how is this disassembled, because I took out these 3 screws and not that easy. By turning the knob to the right position, I got access to the 3 screws in those holes, and then I could take off the entire gearbox unit. I am not able to figure out how to get the knob off because this screw, I took this screw out, and this one is actually a 2-part knob, and there's some sort of a thread here, but it goes in the wrong way or something, so I'm not able to take out this, and I think under here there will be another screw, so that is the reason why I can't get the knob out, and that is required to take the gear out of the casing. But anyway, I think we can still see the gear is made in 2 halves, so there's a spring that presses one half against the other one, and that way there is no slip slap. It's super tight, this gear. So that is definitely how you always do this. By, yeah, I can't actually remember the name for this type of gearing or this technique, but it is just what everybody's doing to prevent the back slack. Yeah, maybe we can actually see a little bit more of it here. Yep, it's definitely, you can also see the corrosion here. Ooh,